Hi guys, and welcome back to another lesson in Algebra 1. Today's lesson is going to be about identifying functions. This is Unit 3, Lesson 1. And so if you are given a set of data points, a data table, what's called a mapping, or a graph, you should be able to tell whether that set of data is a function or not. And when we talk about functions, we'll often refer to it as inputs and outputs, which just makes it sound a little bit more, technical than, it really is. All right, so first thing we want to do is we want to go ahead and review graphing. And so you would have had, plenty of experience of graphing in prior math classes, but we want to kind of remind ourselves what's going on. So we're going to label our x-axis, y-axis, origin, and the four quadrants. And so let's go do that real fast. Alrighty, so my x-axis, that is this guy. So this is my x-axis. So we got that one. My y-axis, that's this guy. My up and down vertical one. So we got that one. My origin, that's just the point where the x and y intersect. And so remember, your origin has the point of 0, 0. Okay, and so that right there would be my origin. All right, so we labeled that. So let's go label our four quadrants. So right here, this would be quadrant 1, and they label them in counterclockwise order. So this is quadrant 2, this is quadrant 3, and then this is quadrant 4. So we labeled all of that. Let's see, so a relation, that is just simply going to be a set of ordered pairs. Okay, and ordered pairs, that sounds all technical, but that's really just the point that we write as x comma y. So, so we can have point A, it says, let's see, it's going to tell us to plot the ordered points and tell what quadrant or axis the point is located. So, this is my ordered pair, just that's the kind of fancy terminology for that guy. So it's going to be 2 comma negative 3. I'm going to go ahead and grab a different color here. I might go ahead and use, well, I'll go ahead and use blue. Okay, so I'm going to come over here to 2, and then because I am me, I drew over, where it needs to be. So it's going to be right here. I accidentally wrote on top of it because reasons. Okay, so that is going to be in quadrant 4. Let's see, we got negative 1, so we're going to come over here to negative 1, down to negative 1. So that's right here. That's going to be in quadrant 3. This is 2, 5. So we're going to come over here to 2 and up to 5. So that's right here. That's in quadrant 1. Let's see, negative 1, 2. So we come over here to negative 1 and up to 2. That is going to be in quadrant 2. And then we have 0, 2. So 0, the x value is 0. We're going to come up to 2. So this guy right here is going to be on my y-axis. And then 4, 0, we're going to come over here to 4, and it's not going up any or down any. It's right there on the x-axis. So that's kind of just your real quick review of, how we graph things. So easy peasy. Let's go on and add the layer to it with identifying functions. So each function only has one input for each output. Okay, and my kind of goofy way of remembering this is you can think of like a soda machine. So let's say, you go and you want a soda, and like here is a Coke label, and this is a Dr. Pepper label. And over here is a Pepsi, and like, let's say this is water. Okay, if you really wanted a water and you went there and you hit the water button, and this time you tried it, it gave you a water. But the next time you hit it, it gave you an energy drink. And the next time you hit it, it gave you a water again. That's really confusing, right? Like, so it's having different outputs each time you're putting in that button for water, this is your input, like hitting this button for water, you are expecting a predictable output. So if you hit the water button, you're expecting to get a water out. If you sometimes get a water and then sometimes you get a Dr. Pepper, that would not be a function, okay? And so if we had a soda machine that did that, that would not be a soda machine that would make people very happy unless they wanted like some sort of mystery button where you get just whatever comes out. Okay, so you can think of a function like that. You know, you hit the button and you expect to get only one answer. All right, so we can do something called, like if it's all graphed, if we're looking at a graph, we can do what's called a vertical line test. And so if your graph is a function, you can draw a vertical line. And there will be only one intersection. Okay. If there was more than one intersection, it would not be a function. So what does this look like? Okay, so I'm going to go through here and, you know, we've got a set of points here and it's asking, is this a function? Well, I'm going to go ahead and grab my highlighter here and I've got, okay, so my x value here is 1, 2, 1, and 5. Okay, notice that my ones repeat here. So this guy and this guy, they repeat. And this is important because if you put in that number 1, sometimes it'll tell you 4 and sometimes it'll tell you 7. That is confusing. So that means that is not a function. Now, sometimes in math, we do have things that work out that way. We just don't call them functions. Okay? So that is not a function. And the way that you can tell is that the x value repeats. Okay? If we see a repeat, then we know that's our clue that it's not going to be a function. All right. Okay, so we got a data table here. So we look, and so this we have a -2, we have a 0, we have a 3, and we have a 6. My x values are not repeating. So this is yes. You know, my x values do not repeat. So that is a function. This is what's called a mapping. It's just a way to kind of summarize your x's and your y's. So that's what this guy's called. So this is my x part and this is my y part. So what we're going to look at here is we've got a -5 and one line coming from it, -3 and one line coming from it, 0 and one line coming from it, and 2 and one line coming from it. So yes, this is a function. Each x only has one arrow. Okay, so it's, you know, only pointing to one number over here. Now let me give you an example of where it's not a function. So I'm going to draw kind of a squished little mapping over here. This is going to be my x values. So let's say that I've got 2 and 4 here. And my y values, let's say I am going to put, you know, -1, 0, 2, and 7. All right. For it not to be a function, you might see something like this, like that 2 goes to -1 and it also goes to 0. And maybe it also goes to this 2. And then the 4 goes to 7. Okay, so the part that makes it not a function is this here. This 2, it's got an arrow leaving, an arrow leaving, and an arrow leaving. This guy would be not a function. Okay, so that's what a mapping looks like that is not a function. And this is what a mapping looks like that is a function. So you have an example of each there. All right, let's see. We're going to use our vertical line test. Okay, so whenever we have a graph, we're going to use a vertical line test. Okay, we should be able to draw a vertical line between any or on any of these going up and down, and it should only hit one thing. Okay, so when we look at this, I'm going to kind of go through this and I'm going to check it off. Yeah, that looks like a function. You know, there's only one, but this goes through two things. Uh-oh. This only goes through one and this only goes through one. So because this one goes through two things, this is not a function. You know, it failed the vertical line test. Okay. So what you're seeing here is when you go back to kind of like this, you know, this silly little soda machine example, like this one up here, this point is -1, 3, and this one is -1, -3. So in that example, you would hit the -1 button, and one time it would tell you +3, and one time it would tell you -3. That makes it be not a function, okay? When you are putting in one x value and it gives you two different answers, or even more than two answers. That's why the vertical line test works, is it's identifying the number of answers you get per one x value. Okay, so that is all the examples. Until next time, my friends, bye.